Okay, let's talk about constants now. To create a constant, it's actually very simple. You just type in the word const, what you want to call your variable, and then we can find that. In this case, we're going to be using a string. And in our example here, it says constant, but we're going to just say this is a constant var. Very, very simple. And then we could just do a format print line and call our new variable that we built. Save that, run it. This is a constant var. So there's a few things that you need to know about constants. When you build these, they are meant to be assigned, like when you compile your code. So you can't define this later on. Like, this cannot be defined when the program is running. This has to be defined, basically hard-coded is what you want. You're compiling this into the code so it never changes, ever. It's also something that cannot change in the program. When the program is running and you have that constant set, your program can't change it. It can't manipulate it. It can't do anything with it other than use the value that you define in it. And constants only work with certain types. You know, like you can use it in like arrays, slices, variables here. And there's a few other places, and you'll see as we go on. Let's play a little more with constants. So in our example here, we have a constant, and we're just going to call this number instead of n, because why not? And we'll just put 5 with a bunch of zeros behind it. And let's define our next constant. We're going to call this decimal, and we're going to use this floating point number 3e20. And we're going to divide that by number. So what's this 3e20 mean? This is just the numerical of 3 with 20 zeros behind it. So it's the same thing as saying 3 times 10 to the power of 20, you know, so 3 with 20 zeros. Likewise, if we change this to negative, now basically what we're doing is we're saying 3 with 20 zeros in front of it, and then there's a decimal point. So that's a really, really tiny 3. But we're going to use this 3 with 20 zeros behind it as our floating point value. And now we can print this just like our example shows. We do a print line and say decimal. And then let's also change this for fun, for kicks and giggies, to an integer. And it's 64. And we're looking for decimal there as well. And then our last is we're going to format print line and call the math module, and more importantly the send function, and we'll call number. So we're going to save this and we're going to run it. We're going to see what results we get. So now we have, this is a constant var, so this is our very first line here, right? Then we get this 6e plus 10. Where was this from? Well, that is a numerical output of the math, and basically making it almost like a string at this point, because it's using the math equivalent 6e plus 10. So that means there's 10 zeros behind that 6, right? Now, if we take that, the integer value, that's where we're getting the actual numerical value. But if we want to change that into an actual decimal representation, that's how we're getting this 0.2518 blah blah blah, because it's taking the whole number with a decimal and dividing it, and that's where it's getting this math from. So now question is, how do you find out, how did I know that this math was in there? Well, for one thing, we need to clean up our code because it automatically added math in here, even though I typoed it, which is the wonderful part of an IDE. But let's just jump over here to go.dev. We'll go to our packages and we'll look up math. This is part of the standard library. And what we're looking for is this sin function. Well, here you go. Sin returns the shine of a radian argument x. And it gives you even an example. So if we take a numerical value and use it, like for example, this one's using mathsin with mathpi, it gives you the output of the expected result. So it's a fantastic, there's all kinds of different functions in this math that you can leverage, in this math module that you can leverage in your programs. And thankfully it's documented to the hilt in here. So by all means, you definitely want to check this out if you're looking for a specific result out of your code. So that's it for constants. Just remember, when you define a constant, you need it to be there forever in your program, never changing. Next, let's get into for loops.